Hey guys, Mr. Wigand. I'm going to give you a chance here to do a little practice on Chapter 6, Sections 5 and 6. So I'm going to do some review problems. You can then pause the video, try the problems on your own, play the video, watch me do the problems, and compare our work and our answers. Alright, so at this point you might want to pause and then come back and watch me. Alright, so problem number one, we're solving the equation. Well, we know when we have absolute value, we're going to get two solutions. So we're going to break this up into two parts. We're going to rewrite without the absolute value symbol, 2x plus 4 equals 17. I'll put that word or because there's going to be one answer or another. We're going to write the same thing, 2x plus 4 equals, but this time we'll put negative 17. Alright, so we're going to solve, subtract 4 on both sides, and we'll do that for both equations. That cancels, 2x equals 17 minus 4 is 13. That cancels. 2x equals negative 17 minus 4 is negative 21. We'll divide by 2 on both sides. We'll do that for both equations. Cancels. X equals, we'll just leave it improper, 13 over 2. Or x equals, and we'll leave this improper also, negative 21 over 2. And that's our solution. Either the answer is 13 over 2 or the answer is negative 21 over 2. Alright, for this one it's a little different. We have a number outside the absolute value symbol there and there. We've got to get rid of those before we can write our two equations without the absolute value symbol. So just like when solving any kind of equation, we always want to do the addition or subtraction part first when we're doing inverse operations. So we're going to add 6 to both sides. That's going to cancel, and we'll have 3 times the absolute value of 4x minus 2 equals 15 plus 6 is 21. Now we'll divide by the 3 to get rid of that. Absolute value of 4x minus 2, and 21 divided by 3 is 7. Right, now I can break it up. 4x minus 2 equals 7. Don't forget the or. 4x minus 2 equals negative 7. We'll add 2 to both sides. Do that with both of these. 4x equals 7 plus 2 is 9. That cancels. 4x equals negative 7 plus 2 is negative 5. We'll divide by 4 on both sides. We'll do that for both parts. And we get x equals 9 fourths, or x equals, we'll just keep that improper, negative 5 fourths. Alright, let's do one more here. Once again, we have some things outside of that absolute value, so let's take care of that. We're going to subtract 12 on both sides. We'll get negative 2 times the absolute value of 6 minus x equals, what, 4? We'll divide both sides by negative 2. That cancels. The absolute value of 6 minus x. There we go, 6 minus x. Equals 4 divided by negative 2 is negative 2. And at this point I'm going to stop because it doesn't really matter what value I put in here for x. If I take the absolute value, I can never get a negative over here. So I'm going to stop and say that the answer is no solution. Alright, now we're doing the same kind of thing here, but we're using inequalities instead of equations, and then we're going to graph them also. So, just like before, when there's numbers outside of that absolute value symbol, I got to do that first. So we're going to add 3 to both sides, inverse operations. That cancels. So the absolute value of 1/2 x plus 4 is less than 9 plus 3 is 12. Right now I can break it up into two parts. 1/2 x plus 4 is less than 12. I just write it the same way without the absolute value symbol. I'm going to use the word and because less than is always and, less than. All right, I'm going to start off the same, 1/2 x plus 4. I'm going to change it to a greater than and make it a negative 12 now. All right, let's subtract 4 on both sides. Do that for each inequality. We get 1/2 x is less than 8. Over here, 1/2 x, they cancel, is greater than negative 16. We're going to multiply by the reciprocal of 1/2, 2 over 1 on both sides. And that cancels. X is less than 16. Don't forget and. That all cancels. X is greater than negative 32. We're going to rewrite this a little bit nicer. Smaller number to the left, bigger number to the right, variable in the middle, less than symbols, and then that's our solution. X can be any number between negative 32 and 16, not including those two numbers. And then when I go to graph it, negative 32, positive 16, open circle, going to the right. No, I'm sorry, that's absolutely wrong. We are connecting them. It's an and. Open circle on negative 32, and we're connecting. There we go. Almost messed that one up. Alright, number 5. Oh, we got a 5 outside, so let's divide both sides by 5 to fix that. Get the absolute value of 2 minus x is greater than 4. And now I can break it up into my two parts. 2 minus x greater than 4. Now that we use the word or, because greater is or, greater. And we'll say 2 minus x. We'll change it to less than and make it negative 4. Now let's subtract 2 on both sides. Do that for both of these inequalities. That cancels, and that minus x is the same as plus the opposite of x. So the opposite of x is greater than 4 minus 2 is 2. That cancels. Same thing over here. The opposite of x is less than negative 4 minus 2 is negative 6. And I don't really want to know what the opposite of x is. I want to know x. So I'm going to divide by negative 1 on both sides. Could also multiply by negative 1 on both sides. That becomes positive. I have to change this to a less than because I I divided both sides by a negative. And 2 divided by negative 1 is negative 2. That's an or. Same thing over here. I get an x. I get to change that to greater than because I divided by negative on both sides. And I get a positive 6. So this is my solution. My graph. There's 6. There's negative 2. Once again, open circles because they're not equal to. And greater than 6 going like this. Less than negative 2 going like that. Alright, moving on. Write the verbal model as an inequality. Then solve the inequality. The distance between x and 2 is at most 8. Alright, so we know these are absolute value problems. The distance between x and 2 means I'm going to do x minus 2. At most. Now, we have to think about what that means. At most could mean 8, or it could be anything less than 8. So less than or equal to 8. Alright. So we wrote the inequality. Now we want to solve it. X minus 2 is less than or equal to 8. Remember, less than is and. X minus 2, change the symbol around, greater than or equal to, make it negative 8. We'll add 2 to both sides for both inequalities. X is less than or equal to 10. And x is greater than or equal to negative 6. Remember, and we always want to clean it up. Smaller number to the left, bigger number to the right, variable in the middle, less than or equal to. And there's our two answers. Write the inequality, solve the inequality. Alright, same kind of problem. This time the distance between negative 3 and x, so that's going to be negative 3 minus x, is greater than 5. Alright, two parts. Negative 3 minus x greater than 5. This time it'll be an or, greater. Negative 3 minus x, change it to less than and make it negative 5. Now let's add 3 to both sides. Do that for both inequalities. Cancels that opposite of x again. 5 plus 3 is 8. Opposite of x. Negative 5 plus 3 is negative 2. I'm going to divide both sides by negative 1 to get rid of that opposite of x. And we get x. We're going to change it to less than negative 8. Or x greater than positive 2. So that is our solution. That was our writing the inequality. Didn't have to graph these. Oh, now word problem. A golf ball is supposed to weigh 1.62 ounces. The absolute error is 0.05 ounces. Write and solve an absolute value equation to find the minimum and maximum weight of a golf ball. Alright, so these are absolute deviation problems. Okay, it's an absolute error. That's an absolute deviation problem. So x minus the given value, 1.62. And then this is an equation, so equals, because sometimes they're inequalities. The actual absolute deviation, or in this example, the absolute error, which is 0.05. X minus the given value equals the absolute deviation. All right, break it into two parts. X minus 1.62 equals 0.05. These are OR problems. X minus 1.62 equals negative 0.05. We'll add 1.62 to both sides. We'll do that for both equations. Cancels, and we get x equals 1.67, or x equals, what do you say, 1.57? So we wrote an absolute value equation. We solved it, and now the minimum maximum. So the minimum, 1.57 ounces, and the maximum, 1.67 ounces, because this is like a real problem. We want to answer it in a real way. Alright, one more. The normal time it takes Mr. Wigand to run a 5K race is 22 minutes with an absolute deviation of 1.5 minutes. Write and solve an absolute value inequality to represent this example. Alright, so similar to the last problem. Absolute value of x minus the given value, that was the 22 minutes. And now it's an inequality. So it's going to be less than or equal to the absolute deviation, which was the 1.5. Alright, so I'm going to break that up into two parts. X minus 22 is less than or equal to 1.5. This is less than, so it's an AND. X minus 22, we change it to greater than or equal to, and make it negative 1.5. We'll add the 22 to both sides. We'll do that for both inequalities. That cancels. X is less than or equal to 23.5, and x is greater than or equal to 20.5. And then we don't leave our AND statements like this, so we're going to need a smaller number to the left, bigger number to the right, variable in the middle, less than or equal to, and then that would be our solution. So we wrote an inequality, and then we solved it. So it looks like Mr. Wigand can run a 5K anywhere from 20.5 minutes up to 23.5 minutes. Alright, that's it. There's your review of Chapter 6, Sections 5 and 6. Good luck with that, and good luck on the quiz.